He developed the theories of gravitation in 1666 when he was only 23 years old. As Newton's science became increasingly accepted on the continent, and especially after a general peace was restored in 1714, following the War of the Spanish Succession, Newton became the most highly esteemed natural philosopher in Europe. Newton has been regarded for almost 300 years as the founding example of modern physical science.
Okay, so there are three laws of motion. The first law is an object that's at rest stays at the rest, and the object stays in motion unless affected by outer force. An example is if you're driving your car at a high speed and you hit a wall. The second law is acceleration produced when a force acts on a mass.
The materials we used in this lab were a beanbag to throw down the hall, a triple beam balance to get the mass of the beanbag, a meter stick to measure the displacement, and a timer to measure how much time it took for the beanbag to stop moving. Our procedure for this lab began with the simple step of recording the mass of the beanbag with the triple beam balance. Next, we stepped outside of the classroom into the hall so that we may have more space to throw the beanbag. Luckily, there was tape on the ground, so we decided to use that as our starting point. Before we started to write down our calculations, we took a couple of practice tosses to make sure we can be as accurate as possible when sliding the beanbag. After practicing, we proceeded to slide the beanbag 3 times and found the total distance traveled all 3 times. It was important to record the following 3 items: the time it took to travel the distance, the total distance traveled, and the mass of the beanbag. As we finished up the lab, we then began to start our calculations.
So this is our data table from the lab. Delta Y is the displacement of how far the beanbag went from start to finish. And T stands for time, so how long it took from when it started to when it stopped moving. VF is when the beanbag completely stopped on the floor. M is the mass of the beanbag, which is the same. And for number 1, this is the equation that we plugged our numbers from the data into. And so these are the numbers that we plugged in, and then we solved for VI and got 4.88. This is the second equation that we plugged in, our numbers to find acceleration. And for acceleration, we got negative 2.66. So this is number 2, and we plugged in the numbers from our second row into that same first equation. And for VI, we got 6.54. And we solved for acceleration and used that same equation to solve for it. And we got acceleration equals negative 3.75. And for number 3, we got 6.62 for VI and negative 4.13 for acceleration.
So this is our first equation. We had to plug in our mass, which was 0.8248 times the acceleration, which was negative 3.5. And for our F net, we got negative 2.88. For our next equation, we had to plug in our F net that we found in the last equation, which is negative 2.88, equals the applied force, which was 0, and then plus Fk, which we are looking for. Then our kinetic friction was equals negative 2.88. So with this equation, we had to plug in the kinetic friction, which is negative 2.88, equals the coefficient of kinetic friction times 8.08, which we found in the last equation. No, that's a lie, which was mass times 9.8. Then we got the coefficient of kinetic friction, which equals negative 0.38.
Results of this lab represent why the beanbag doesn't continue to slide in the floor, in which is answer our hypothesis we made of how the friction makes the bag slow down and how the acceleration is slowed down as well. The friction force is how the force be applied to an object to move. The coefficient number is basically how the gravity the forces are in which is what slow down the object moving.